Questions today? Kelsey, go ahead.
First worksheet on the last question. I'm getting a run for
Last question on the first worksheet. On the front side or the back side?
front side.
Front side, the grenade question?
Yeah, I'm just, I
Okay,
put
so
it
I
together.
got a 0.4 kilogram piece at 20 meters per second to the north. So my P1 prime is 8 kilograms meters per second, right? North. My P2 prime just like that. Okay.
Isn't it 16 degrees
Oh, 60, that's 30. That, right?
and 90
Okay,
kilograms
and then
meters
so-
per second?
I start up here, there's no motion before.
Isn't it supposed to be 90? 90 kilograms meters per second? Because it's 30 times 3.
0.3,
It's 30.
0.3.
We don't have that on here.
It's kind of
Turbo punch.
0.3.
Just a bigger A.
So can you solve it now?
Probably. That's probably why it's giving me the number. Okay.
You want to try it?
Yeah.
Okay, so I'm just going to go through this. So this goes for everybody that's doing this question. Again, you're going to see a couple of these on your test for sure. When you get to this point right here, you have to start with your law of conservation momentum. So I'm going to move P3 over here. So if I add P2 prime with P1 prime, by drawing them out, I'm going to end up with a negative P3 prime. Okay, so draw my P1 prime. My P2 prime is up here. And this right here is my negative P3 prime. So the only thing you need to do when you solve it is just worry about your angle down here. So the angle that you're going to get when you solve this will be north so many degrees to the west, but that's the negative P3 prime. So what is P3 prime equal to? It'll be south so many degrees, the same angle to the east. Okay? So I'm not going to do the question out for you right now because I think you want to try it, but it's essential that you do this every time. Anytime we work with vectors, you do not substitute into the equation. You use the equation to draw your vectors. It tells you how to draw them. Alright? Okay? Kelsey, you working away on it?
Mm-hmm.
Okay. If it doesn't work, we'll come back to it, alright?
Okay. Do you expect us to have this whole thing done?
Do as much as you want. You've had it in your hand for 5 days now.
What?
Since last Friday. So yeah, two worksheets in 5 days. Yes, you should have it all done. By your test is my point. You can do homework once in a while.
3 days.
Mm-hmm. It's your own fault for not getting it on Friday. You're digging yourself a hole here. Any other questions? Mary, go ahead.
Can you do 2 on that page?
2 kilogram ball one?
Yeah.
Okay, I'm gonna do this a little different. I'm not gonna do the question for you, but I'll show you how to set it up. Okay, you have a ball right here, and it's 2 kg, and you're shooting it towards a 4 kg ball right here. Alright? Now, if you were to hit it, excuse me, if you were to hit it dead center, okay, this ball would go shooting that way, right?
Yeah.
This ball would either keep going that way after it hits, or possibly bounce back, depending on all of the things that, like, depending on its initial speed and all that happens there, right? But in this case, it doesn't hit it dead center, it hits it on an angle. So, even though it hits it, it's drawn as if you hit it, this ball here deflects and goes down this way. Okay? So that's my 2 kg ball that's down here, right? So if I hit this one on an angle, so if I hit this such that it goes this way, then that one's got to go up that way somehow, right? Okay so far? Alright, so I only have the momentum of the 2 kg ball beforehand, right? Because this guy's at rest, so his is 0.
Yeah.
So the only momentum before I hit is the momentum of this guy, which is 2 times, what's his speed?
14.
Speed's 14 meters per second?
Yep.
Okay, so this guy's momentum beforehand is 28 kg meters per second. That's his momentum. You've got that so far?
Yeah.
Okay, so now P1 and P2 prime. So I'm going to say that, I'm just going to change this a bit here. This is going to be my P1, so that's the P, this is this guy right here, right? If you just leave your pen, I'll leave this up for you to look. Alright, so this guy goes here and then down here, so his P1 prime is down there, right? The P2 prime is the 4 kilogram ball that goes up that way.
Okay.
Okay so far?
Yep.
So that's the drawing that they've given you, correct? Okay, but I need to solve for P2 prime. So I have to arrange the equation so that I get P2 prime by itself. What does P2 prime equal?
P1 prime, or P1 minus P1.
Yeah. So I take the P1 before the collision and I subtract the P1 after the collision to occurred, after it's hit it, right? Well, this is the positive P1 right here. It creates an angle of 120 degrees. But I need it to be a negative P1 prime. So I draw it that way. I have to draw this in its opposite direction because I need it to be P1 prime. I'm subtracting from my original. You follow me so far? This right here is P2 prime. This angle is 60 degrees.
I think I can read the question. So, it's just,
Okay.
I had trouble with the
Well,
angles.
you probably are trying to solve this question using the original diagram. We can't do that. We have to draw it based on my equation of P2 prime is equal to P1 minus P1 prime. And you have to do that for every one of these questions. The same way I did it for this question here. How did I solve and get P3 prime? I subtracted it to this side to isolate it. And I found out the negative P3 prime is equal to P1 plus P2 prime. Okay? Now it sounds like a lot of words and everything, but all it basically is the 2 kilogram ball hits and goes this way. But in order to solve for what this ends up being, I have to, because if you look at it, this guy is actually parallel to that right there. It's the same line. Okay? I've moved it over to here based on P1 minus P1 prime. And you have to do that all the time. Does that help you?
Yeah.
Okay. Alright, next.
Number 5 on the last page, and that's it.
Cue ball again.
The same thing?
The cue ball, moving at 14 meters per second, glances off the 8 ball. If the 8 ball moves at 6 meters per second, find the direction and velocity of the cue ball after the collision. Okay, well, this is the same thing that you came to me with yesterday. Alright? You have 2 balls on the pool table. Right?
Right.
So you're taking the cue ball and you're going to hit the 8 ball with it.
Okay.
So after the collision has occurred, each ball is going to move in a certain direction.
Yeah.
Alright? Now, it says all the masses are equal. So I can work with just velocity now. So basically what I'm saying is V1 plus
V2.
V2. But what's V2 in this case? What's the 8 ball at? Is it moving before?
It moved after the cue ball
But
hit.
before it's at rest, right?
Right.
So that's actually 0 meters per second. Correct?
Correct, yeah.
That's my cue ball. Okay? Follow me?
Kinda. So it's
So it's hit. Okay, so now the cue ball's moving at, V1 was what? How fast was the cue ball moving? 14 meters per second?
Yeah.
So the cue ball's moving at 14 meters per second. It hits the 8 ball. The 8 ball shoots off this way.
Yep.
The cue ball, we're not sure about.
Yeah.
8 ball moves off at 6 meters per second.
Mm-hmm.
Can you find out V1 now?
Yeah.
How fast and what direction is the cue ball moving? You don't need your calculator, bud. Okay, V1 by itself.
I can't do 14 divided by 6 on my head.
That's good, because you don't have to. It's V1 plus 6.
So it'll be V1 will be 6. It'll be 6 V1, and then wait. Is it just 6? Or
No.
am I?
Morgan, you got 14 equals V1 prime plus 6. What's V1 prime equal to?
Oh, okay, now I'll do the math. 8.
Because it's positive, it means it's still moving in that direction.
I don't think that's how we're supposed to do it, because it said glancing off, so wouldn't that be like angles and...
Well, you'd think so, right? And it does have that. So,
And 8 meters per second isn't what the answer says.
no, it isn't. It's 12, not 6. Okay, my bad. You should have done it. Sorry, Morgan. If they were going in the same direction, if it hit it dead on, this is how I would do the question. Okay?
So I add.
Well, no,
Or what I was doing before was right.
yes. Okay? But it's going off at an angle, so I'm gonna do this again differently.
Okay.
So, I've got V1 is equal to V1 prime plus V2 prime.
Okay,
Okay, because equal masses, I'm gonna get rid of the masses, right?
right.
So this is actually done the exact same way that the question on, the first question on the sheet was done. So I've got the cue ball going this way. I'm gonna say the 8 ball goes up this way, and the cue ball comes this way. Just like that, okay?
Okay,
Now because they have equal masses, this is V1 here, this is V1 prime, and this is V2 prime. So
yep,
far so good? So I gotta draw it like this though. So I need to take V1 prime and I have to add V2 prime to it. So I've gotta take this guy and move it down to here.
so take V2, move it down,
Take this guy, this vector, and move it right to here.
okay,
So it's going to look like this. V1 prime. I'm gonna move that V2 prime to here. Like that, right?
right,
It's gotta equal that guy right there,
okay,
which is V1. So far so good?
yep,
This is 14 meters per second. Which ball is moving at 6? 8 ball?
yeah,
That's 6 meters per second. You can now calculate V1 prime, cue ball.
okay, I did,
This is a right angle.
okay. 14's a hypotenuse, right?
Yes.
I did something like that.
Okay.
For that side, I got 5.47.
Okay. How did you get 5.47?
I used right angle trig.
Okay.
I used cosine.
You don't have an angle yet, though, Morgan.
Oh,
So
Wait.
what do you do when you don't have an angle? When you have,
use tan.
no, you don't have an angle, you can't use trig. So what do you do when you can't use trig?
Use tan -1.
You can't use trig. What do you know about the 3 sides in a triangle that's a right angle? Heard of that guy Pythagoras before?
Oh. Yeah, Pythagoras theorem.
You have to use it. And then you use the 2 sides to find the angle. And you find this angle right here,
Okay.
okay? Alright,
All right.
so 14 squared subtract 6 squared, and the square root of it will give you V1 prime,
Yeah.
okay? And then you're gonna find your angle after, right? Mary, you had your hand up?
I wasn't getting it right. The one that you showed me. Like if I didn't get the calculation.
Okay, so what's P1, how fast is this 2 kilogram ball moving?
Like initially is the 14,
Yeah, and after?
and after it's 6.
What is it?
6 meters per second.
6, so this is 12 then? Yeah?
Yeah.
Okay, so then P2 prime is equal to you got all that?
Yeah. I did that and I got like 35.
What do you get, sorry?
I got like 35.553 and then I
Okay,
divided
so
it.
that's your momentum, right?
Yeah.
Okay, now we need to divide that by the mass. What's the mass of it?
4.
0.4?
No, it's 4.0. It says 4 kilograms. Was the second one?
I got 24.221 when I did it.
Mr. Newton?
Which question are we on? We're on 3, aren't we?
2.
Oh, 2.
Mr. Newton, I got 24.331 when I did it on my calculator.
This?
Yes.
I think I had like 28 and 12 switched, or I had like minus 12. I guess I got it. Is that wrong to put minus 12 for that?
Where did you put minus 12 in there?
For like not minus 2 times 12, I put minus 2 times negative 12.
Yes.
That's
It will
wrong.
change it, yes.
So like why isn't it a negative if it's negative?
The negative only implies direction. It doesn't change the number ever. You never ever make it a negative number. The only time I use a negative value in momentum is never with vectors, is if I'm moving in straight lines. And one's going right and one's going left. That's the only time I make the value itself a negative. Okay? So otherwise, it's always going to be a positive. I'm just using this in this part of the question, but the number is always going to be a positive momentum. All right? The only time that the velocity is negative is if you're going left and right. Only left and right, or up and down, whatever, north, south. Okay? Okay. So what was it, sorry? 24 point?
331.
I got it now. It works.
Okay. All right. Other questions?
I did it, and I'm just a little bit off, like from the answer. I got 73, but, yeah, okay.
What'd you get?
73.655.
Okay, let's just have a look here. So, P1 prime is 8, right? P2 prime is 9. This angle right here is 60. So that makes this angle right here 120. Did you use that?
I did it components, right?
Okay, okay. So, what did you get? This right here is 4.5, right?
Mm-hmm.
And this right here is
7.794.
794. Okay. All right, so using components then, I'm going to go X, Y. I've got 7.794, and that's west, right?
Mm-hmm.
And then I gotta add 4.5, so that's gonna be 12.5. North. Agreed? Yeah?
Yeah.
So now I've got 12.5 meters per second. That's P1. Oh, I don't really need that. I'm just gonna do this because we're using components. So this is 7.794 right here. Right there is my negative P3 prime. So negative P3 prime is equal to, I'm just going to change this, this. Okay, so 12.5 squared plus 7.794 squared, what do you get?
14.731.
721?
31.
31 kilograms meters per second. Okay. My angle is what? So second function tan, 7.794 divided by 12.5.
I got 34.25 or 215.
34.215 degrees
Mm-hmm.
west.
And
Okay.
that's even a little bit off too.
That's off as well.
Yeah. By like 3.
I think you're doing okay so far. I guess I'll just check your math, but somebody else get the same as you?
And yeah,
Jake? You got the same there, Jake? Okay, so the first thing I'm gonna do is go, sine 60 times 9, 7.794, I got the same as you there.
Yep.
So square root 7.794
I
squared,
got 31.944.
12.5 squared. Just a second, right? 14.731, I get the same as you there.
oh yeah,
And then I'm gonna divide that by 0.4, 0.3 divided by 0.2. So I get 73.654 meters per second. Is that what you got?
yeah.
Okay, so I'm off on this a little bit as well. And then,
Angle I just didn't fix after I did the other way. So yeah, it's 31. I did it.
31.944.
I get 31.944 for the angle. Is that what you get?
Yeah.
31.99, oh,
944.
944. So then it's south 31.944 degrees east. There's your answer.
Okay.
Okay, I'm gonna do this one just to, I'll do this one just using coast, just to see what I get for my P3. So I've got second function square root, so now I've got 64 plus 81 minus 2 times 8 times 9 times cos 60. No, I need cos 120, shoot.
It's the same thing.
So I got 14.731. I got the same answer doing it using a lot of cosines.
Okay.
So that's, you're right. So the answer's off by a bit.
If you round the 14 to 15, you get the exact answers in the book.
Yeah.
So they just rounded to
So
two
they rounded-
significant figures.
They rounded the 14 up to 15, you said?
Yeah,
So 14.73 to 15?
yeah.
Okay.
So if you take the 15 and divide it by 0.2, you get exactly 75.
Okay, good, thanks. Okay, you're good. Thanks, Kevin. Okay, any other questions today?
Is it okay if we do number 6 on the back page? On the back, the back. of the
Bottom one?
booklet. Yeah.
Initially at rest on a smooth. 3 pieces, all right, so let's do this again. 0 equals P1 prime plus P2 prime plus P3 prime, right, Morgan?
Right.
So negative P3 prime equals P1 prime plus P2 prime. Yeah? Alright. Explode it into 3 pieces. 2 pieces fly off horizontally at 60 degrees of an angle to each other. 2 kilogram, 20, 3 kilogram at 12. Okay, so realistically, they would fly off, let's just say they fly off like this, Morgan, 60 degrees, okay?
Okay.
You following me?
Yeah, I'm following, yeah.
Okay, so this is P1 prime and this is P2 prime. Got it?
Yeah.
Okay, now. Bear with me for 1 second here. I need to move P2 prime over here, Morgan.
Okay.
Okay?
Okay.
So I take it from here and move it up to here, as such. This is gonna make this 120 degrees right here.
Okay.
Okay, that's P1 prime plus P2 prime. Remember the dog sled question? We did the same thing. When we don't know the actual angles and directions, we take this one and we move it to here because the add, you have to have tip to tail.
Okay.
So now I just have to erase this here. Like that. So I have this now, in which that right there is going to be negative P3 prime. Follow me, Morgan?
Yep.
You just have to find the angle that goes from like start to finish.
If there's 3 pieces, you always start with a 0, because P1, P2, P3.
No, I don't start with 0 if it's moving beforehand. I don't think any of these are moving yet, but the one in the textbook that I gave you, it moves. You will have one of those too.
What about the, okay, like
It's
the,
actually easier
So
than,
you start with P1 in that case?
yeah.
so, sorry. The second one, like what Mary did, that one would be a P1, correct? Because it's moving at 14 meters per second, so you,
No, not before, it's not moving beforehand.
but it's like
It's moving,
before.
oh, like, the one Mary did in 2?
Yeah,
Yeah, that's a P1, that's
Okay.
right, yeah. Sorry, she asked about the ball and you're asking about the pool balls. Are you good?
I tried to do that on my own and I butchered it.
You're butchering it right at this part right here, from here to here. Every time. It's drawing your pictures. That's where you're going wrong. Your math is spot on.
Well, I got the P1 and the P2.
Yeah.
At the bottom part of it, I messed up. The angle, I used 60 degrees on it. I didn't do the 120 degrees.
That's because you drew it like this. Remember, if what we said before, if you have two vectors that are attached by their tails, you're actually subtracting them. We don't want that. We want to add the two vectors together. So you have to move this to here. Okay?
Okay.
Alright, so it's just drawn. Morgan, there's only two types of questions that I can basically, well, there's three types. There's three questions that can get asked. The first one is the pool ball question, in which they move off in a direction. But for exploding questions, there's only two ways I can do it. The first way is to do it this way, where I tell you the angle between the two, and you have to move one to the other. Okay?
Okay.
The second way is I'm going to give you the directions of them. And then you draw them out based on their directions.
Like vectors.
Like vectors. Same as this.
Yeah.
There's only two, so you just have to keep practicing your drawing of them. Okay? You know how to use the law of cosines, you know how to use your law of sines. You can do that. You're good at that. It's just drawing this that you have to hit over and over again. Do it as many times as you need. But they're the same questions. Question 3, question 5,
I do them over and over again. I get
question
wrong.
6. They're all the same question.
so then go with the
Okay.
momentum and be 14. Yeah.
Just keep hitting at those, keep trying to work on your drawings for them. Don't worry about the math, do the drawings, okay?
Okay.
Alright? You finish this off and then come back to me. If you don't get it, come back to me.
Alright.
I just have a question about how to draw these vectors. So if I have them going north, and then one going 60 degrees northwest,
First question I did today.
yeah.
Okay? Work on that.
Okay.
Okay? If you can't get the answer, I'll do it with you again.
Okay.
But it's just drawing. You know how to work with triangles. You just gotta figure out how to draw them.
Yeah.
Two ways to do it, okay?
Alright.
Alright. Anybody else today? No one's asked anything out of the textbook. Are you okay with the textbook?
I don't know what to make
Our
of.
test is going to be more like the worksheet than the textbook. So
No other questions?
I'm trying to see where it's located here.
Okay, we'll work on that question you just did here, Morgan. And then if you find another question, we'll work through it, okay?
Okay.
I wanna make sure that.